Have we done foundations before?
Just a little bit of like bags. So we discussed about the foundations, Raft foundation, something like that. So what do you suggest?
So we need to look at the Raft.
Yes, and we can do that. Okay.
So there are two ways that we can use to analyze Raft foundation. We could start with one that is relatively easier.
Yeah.
It's not a Raft foundation. We need a model. Do you have any model here?
Yeah. Model.
This one.
The same model we used last time.
The same one we used last time. Do we have a template for this one?
What do you mean template?
Template, the one that the pads file that we used to generate this.
Yeah. This one template.
So this is a template for this file for that frame.
Yeah.
Now, one of the things that we need to do is we need to, if we are doing a rough foundation for this building, we have to create a pads file for the Raft foundation. So
first of all, before you decide, this building will have Raft foundation or a basis.
the moment, of course, you must have tried basis to work with the basis, and the moment the area of the basis starts occupying more than 50% of the footprint of the building, it will be cheaper for you to do a Raft foundation than pads foundations. So that's one rule of the thumbs that quickly helps you determine.
Geotechnical also helps when you see
That's correct.
visual observations. When you see this is not work with Paris, the type of also you see.
Yes.
Self-governed.
Yeah.
Software.
That's correct. But it's the same thing. It was almost the same thing I'm saying. You see, the moment the soils are not good, the bearing pressure is low. The separating pressure is low. Then the area of the pads would be more. You see, because the pressure is low, the separating pressure is low for the soil. Then they will occupy a large footprint. So that's why I say at the point where you find that they are now occupying more than 50%, then you would rather do a Raft.
And software will give you, once you put lower bearing capacity,
You will know.
So bigger price.
Have we done basis?
Yes.
Not
Yes.
we have done basis foundations before in the program. Okay. So that's how we're going to determine. So if we look at
so we assume now we decided to do that.
Yes, just assume at this point we have already decided we are doing Raft foundation. So let's also assume this Raft foundation we have already demarcated where it's going to pass. So let's say it will be 1 meter or from here, 1 meter off, okay, 1 meter off, okay, 1 meter off, that way. Okay, to cover that. So let me create a new layer. Say Raft. Template. Allocate current and put it on. So I'm going to start with M1. So let's say our Raft occupies that area. So when the Raft occupies that area, we have to now get go to the model. We have to go to the model first and get the forces that are coming into this raft. So let's get the forces that are coming into this raft. The forces that are coming into this raft. We have to analyze this. So it's the error. Section 2 is not defined. Section 3 is not. Let's go down to section 2, which is this one. It's auto-group and see if we can pick up the error. So number 1 is the this is number 1 is there. Number 2. We see rigid links. Need to draw rigid links. Rigid links there. Let's correct this model first.
Change group number only, that's what I did.
No, don't change group number only. You have to change even the section length bar. So we apply. So I think that's error is, so we don't have an error now. Let's explore it.
Explore this with the
unnecessary data.
That's the most important.
Yes. Because you have done so many things. You have deleted, you have added, you have changed, so you want to remove all clutter and have a clean one. So you explode. So you explode notes. Compress node numbers. And then we go to beams, explode the beams, explode beams there, and then explode shells. So you want to explode everything, you don't want another error. You have the shells, support, we explode, exploit supports, exploit beam nodes, exploit beam nodes, exploit shell nodes. There we are. Let's check the load combinations. Yeah, okay. So we analyze. Go to analysis. So we still have an error. Which one is this? Section 3 is redundant. Are you sure you haven't used section number 3? So, and that is not used. It's not used. So we have section 1. We have used section 1 for the beams and for the columns. Yes, sir. So what we're going to do is change beams to section 3. So I'll pick all the beams. Let me use the formula. Pick all the beams and move to section number 3. I'll move to section number 3. So group number 3, let's say.
The issue was also sticking that on the group number 1.
That's the reason. So we have changed that. So because of that change, we have to explore the beams. Beams, explore beams, beams. Explore beams. Okay. So I'll prefer if section number 3 is a column. So number 1 is a column. So can we make it slightly bigger? But let's make it square columns. Or what did you have in mind? Is that what you wanted to use? Yes. It's 250 by 500.
Yes. Or you continue to 450 by 450.
Okay, that's one way, because I felt that it's going to be a bit small for that period. So let's analyze.
So you want to build the forces.
The forces that are going to the foundation. That's what I want to pick. So the analysis is complete. So just go straight to output. Yeah. Output file. At the output file, I'm going to look down here. I need reactions. I need these two. Reactions SLS, reactions ULS. So I will uncheck all these. You see? Then I'll send this to Excel. So here we are. These are the forces that are coming to the foundation. The forces that are coming to the foundation. Now we have to now change, because this is for node 2074. You have this deadline combination. You know, we are interested in we are interested in this is UNS, it's SLS. SLS is just SC1. So we are interested in SC1, a load combination. We're not interested in the live load only or the dead load only. It is a load combination.
Yes.
According to the foundation. So it would have been better if we analyzed load combinations only. We did our analysis from here. We did analyze load combinations only. So let's reset and analyze. So we close this. So we reset, and start reanalyze.
The green tab load combination. The taxation.
So this is fairly easy. So our file, again we just need these two, let's send to Excel. This is the Excel file. So this Excel file is giving us load combination 1 for UNS, and for SNS we have load combination 1. So we already have the forces that we need, but we want to if we look at our template, where was our origin? Where was your origin? Here. So if you check the distance, it's a meter. See, it's a meter. In this one, so this is 2.2. So it means the origin of the raft is different from the original origin. You see. So if this point was 0, it has become, in X it has become 1,000 or 1 meter, and in Y it has become 2.2/5. So all X values are increasing by this, and all Z values are increasing by this much, but negatively, because Z is negative this way and it's positive this way. So we're going to change the values from this output, this X. We need to get the nodes. Okay, like this node, the coordinate, we are going to modify it so that for X we add this much, and for Z we subtract this much. So let's get those coordinates. So again, going back to the model, this is the model. Input, of course, the coordinates can always be found here in the nodes, but this is coordinates for every node. We want to extract the coordinates for the foundation only. So let's copy all this. Again, go to Excel, another sheet, and paste them here. These are for the entire building. This is node number, that's X, Y, and Z. So you can see here, node number, X, Y, Z. But how do we get the nodes for the foundation? You will notice that the value that's going to give us the nodes for the foundation, because foundation are the lowermost nodes. So the height, this is the height y. So the y must be the least for the lowermost nodes of the foundation. So we're going to pick this, Control Shift down arrow, and then we sort smallest to largest. We expand the selection. I've seen them. So the values that are from here, negative 4.5 up to this point, are the ones for the foundation. So we are going to again shift the Control Shift down arrow, delete. So these are the nodes for the foundation. But for us to modify these values, we are going to change. This is the node number. The x, we are going to add a meter, is equals to this plus 1. Are you seeing that? Yeah. The y is going to remain. The z, we're going to subtract this much. 2.205. Is it 2.205? Good. Minus 2.20 is equals to this minus 2.205, isn't it? Now these ones we do. Let me close it here so that we're able to drag. These ones we do all the way to the bottom. You see, all the way to the bottom. And we copy and bring here, and we bring. So we copy them, we bring them back exactly the same as we going to put them there as a coordinates. Can you see? Now this is the node number for a node of the foundation, x, y, z, and you see they are tallying. This is 2093. This is 2093. This is 2105, 2105. If you want to be sure they are tallying, you can is equals to create another column there is equals to this minus this. If this value is 0, then they are tallying. You see? Yeah. Then try it all the way. Yeah. Again, if the sum is 0, they are okay, isn't it? Okay. So let's see that they are tallying. We can now do away with this one because it's the same as this one. We just want to confirm that they are tallying. So this is x, this is y, and that is z. Let's see that. Now, if you see, so we have these values at the foundation level. So we have the forces, x horizontal forces, this is the right combination, horizontal forces, y forces vertical, z forces again horizontal. These are the moments. We don't have any moments because these moments are there were 0 moments. They were pin foundations. They support the foundations are pin. So we continue. For us to get the direct stress is going to be which one? The recording. Which one? This one here. Stopped.
Can be recorded.
Recorder is recording. It's actually recording. Yeah, it's recording. Okay. So we go back. Yeah. And it's here. So let us get the summation. This is the y force. So this one. This is the y force. Let's give it some color. Y force. You see the y force? There it is. The sun color. Let us get the sun. What the sun? There. That's the sun. So I'm more concerned about the y force. So this is the summation of all forces. This is the total weight of the building without any factors of safety. So from there we do this one. We want to get the center of forces. Yeah, want to get the center of forces. Let's have another column here. This is P. You see, this is P. Let's call it just that's P. This P is the y force. So let's get P of x. This is P of x. I mean P of x. This is P of x. We want to get the center of forces. So the P of x is going to be this times x value there. Listen. Then we get P of y. P of y is going to be, because there's a change of axis, this is x, this is y, but in the frame is z. That's z. So y is actually negative z, because y is positive here, but z is positive this way. So this is going to be P of y. It's going to be P times negative z. It's going to be equal to P. You multiply by negative z. You see. So again we have to sign So let's get the center of forces. Is going to be the center of forces in x is going to be summation of p. Summation of p of x divided by summation of p. So we call that is the center of forces. Call it EF, a center of forces in x.
Yeah.
Enter center of forces in x is going to be summation of forces in x divided by summation of p of x divided by summation of x. It's 15.9. Center of forces in y is going to be summation of p of y divided by summation of p. So the center of forces and centroid of the forces is this point, which is 15.9 from the origin. Let's check it. 15,900. And in y, 9.261. 261. Y is when 9261. Yeah. So this place where the two lines are crossing here is in that point and this point. That is a center of forces for the building. That is like the centroid. So it means your building is slightly heavier this side than this side. There's a reason. There is no perfect symmetry. There's some heaviness here. Could you belong with the reason? No. Okay, let's see. We're supposed to measure from here. So from here we have measured correctly. From this side, 15.9 is from here. We measured from the wrong place. Let's see it again. 15,900 gets us to this point. That's the center of your forces. So the building is symmetrical. The building is symmetrical. So the forces this side and this side they are similar. Symmetrical. So let's again get the center of forces. Show it there. There. That's the center of forces. So now we need to get the center of the raft. Yeah. Now we have the center of forces. Now we need the center of the raft. Yeah. So how do we get the center of the raft?
Because we expanded 1 meter.
Yeah, because now we would have learned more if the center of forces and the center of the raft were different. But let's see. Because now the building is symmetrical, the forces are at the center, then at the center of the raft. So there are some things that are going to cancel out and become zero, which would have helped us to learn over this route. So let's get the center of the raft. So to get the center of the raft, we have to reduce this center of the raft, center of the forces. So similar. That's better, isn't it? So to get the center of the raft, let me put on all the other layers and to get the section properties of this raft. So MG section properties here. Click there. There's no opening. Escape again. So it brings us here. See, settings. We are working in meters. Okay. From there, check the properties. Now, let's share. Yes? No, because of this dimension, there should have been another layer. Let me create another layer dimensions for the dimensions. Allora, tiro via. Via via te avanti.